Hello everyone, myself Pranavesh Chakrapani from GM University, CSECY. So today we'll be presenting on our PBL project topic called Smart Surveillance System Robot, which is powered by IoT. Project guide is our HOD sir, Dr. Arun Kumar Beti, and our PBL coordinator is Nana MR ma'am. So this is the contents of our PBL project. Introduction, literature survey, objectives, scope of the project, software and hardware requirement which is required to complete the project, methodology, expected outcomes, and conclusion. So let me introduce to the project first. This is a next generation autonomous mobile surveillance platform, which is basically used to deploy the system or the vehicle where human surveillance can't be is not optional everywhere. So it is here next generation autonomous mobile surveillance system which is engineered for hazardous and inaccessible environments. This is powered by IoT based systems like Raspberry Pi, ultrasonic sensor, GPS model, accelerometer, and also motors and other kind of stuff. This has both integrated vision, motion, and location and safety monitoring system, which is a perfect package of everything is needed for a surveillance thing. It has a vision, which is gives out live streaming and motion detection by accelerometer and location by the GPS module, and also safety monitoring by the machine learning and alert system in that. It can be used in multiple applications for security patrol, disaster response, research, hotel management, other kind of stuff. So this is a multi-purpose kind of surveillance robot, which can be used in many multiple areas, and also this is very much required for nighttime and also used for safety of people and road safeties. So these are the literature survey which we have been referred to complete this project. The technology adopted for all of them are remote monitoring via IoT, live video streaming. This is the IoT-based smart system surveillance system. And IEEE journals called robotic operating system, which has motion detection, face recognition, and AI-based alerting, which uses basic AI algorithm for motion and object detection. The motion detection is done by the accelerometer, and the vision object detection is done by the camera and ultrasonic sensor here. And for the motion sensors and IoT alerts from Internet of Things, vision, architecture elements, and future directions, the motion sensors, as said before, are ultrasonic sensors and accelerometer, but priority alerts are given by the AI machine learning. And also, the Springer Handbook of Robotics gives us the autonomous navigation, which is remote control, basic controls like forward, backward, right, and left, and also object detection and live camera feed given in the interface of the dashboard. The problem statement for our project is traditional surveillance systems is fixed CCTV and manual security monitoring, lack mobility and continuous coverage. As you know, CCTV is fixed in one place. It can't be surveillanced everywhere. It only gives us a particular area or something. But here the limitations can be reduced by deploying the robot, which goes to some certain range to and covers a large area compared to a CCTV or other kind of thing. Also, this robot can be also used for multi-purpose as a drone. By removing the wheels of the robot, can you use the planes and other kind of things which can be used for flying. So here the limitations reduced effectiveness in large dynamic and hazardous environment. To address this, there is a need for smart mobile surveillance robot, which I said before, which is capable of real-time monitoring, obstacle detection, live video streaming, and remote communication to enhance security with minimal human intervention. Here, the remote communication is done by the mobile or any kind of network system remotely with anywhere in the world. So next topic will be explained by Mazin.
So good evening. Good evening. Myself Mazin here. So my topic is the objectives of our project. So here we have given three topics here for the objectives: to design, to implement, and to develop. So the first topic is to design. To design a smart surveillance robot that can move autonomously, monitor surroundings in real time, and avoid obstacles using sensors and cameras. So the first objective of our project is to design a autonomous moving robot which can monitor its surroundings, surveillance its surroundings, and avoid obstacles using sensors and cameras. So, and the second point is to implement motion detection, live video streaming, and wireless communication to send alerts and surveillance data to a remote user. So the second point tells us to implement the motion detection, the live video streaming, and the software and hardware components like the Raspberry Pi which I have used, and the webcam for live video streaming, and the other IoT components. The third point is to develop a reliable and cost-effective surveillance system that can ensure continuous operation, quick response to threats, and future scalability tasks. So the third point is to develop a reliable and cost-effective surveillance system which can be affordable yet effective for the society. For the surveillance system, it must be quick to threats and for emergency tasks. Next please. So coming to the hardware and software requirements of our project. In the software, we have used programming environment like C and Python programming languages, wireless communication protocol like Wi-Fi, Zigbee, and Bluetooth, and the operating system software for our Raspberry Pi is the Raspberry Pi OS, which commonly called as the Linux Raspberry Pi OS. And for the hardware requirements, we have used the microcontroller, a single board computer microcontroller, in the sense Raspberry Pi. The camera module is the webcam we have used, motor driver and DC motors. We have used the H bridge which connects the DC motors, the ultrasonic motion sensors which have been placed in the front of the robot, power supply of rechargeable batteries which are 2000 mAh per each, powering our project, and the robot chassis which we have attached four wheels attached to the motors. So this is the project, this is the flowchart of our project. So here is the battery supply which provides the power to our project. Here is the camera, wireless communication module, motor driver, microcontroller, sensors. As I said earlier that the we have used webcam for our camera, wireless communication module means Wi-Fi, Bluetooth, and all, and microcontroller is the Raspberry Pi. Motor driver means the H bridge. Motors means individual motors for individual wheels for operating the forward and backward movement of the project, and sensors like the ultrasonic sensor and other sensors. Which point? It will be continued by my teammate Sonal Vaishnav.
So this is my topic. The first is requirement analysis. First, we studied the need for better security monitoring. We identified the problems like lack of continuous surveillance and human effort. Based on this, we decided the system should support motion detection, obstacle sensing, and live video streaming, alert generation. The second is the system design. Next, we designed the overall system architecture. All components are connected to the microcontroller. Sensors detect the motion and obstacles. The camera captures the live video. The wireless module sends data to the users. The motors help the robot move as required. The design ensures smooth coordination between the hardware components. The third is front end and back end development. We developed a user interface using a web or mobile application. The front end shows the live video feed from the camera. It allows the user to control the robot remotely. The back end processes sensor data and send alert when needed. This make the system user friendly and efficient. Overall, the methodology helps using in building a reliable, smart, and real time surveillance system. Next will be continued by Harshita.
My topic is expected outcomes, real-time area monitoring and video surveillance. The system can continuously watch an area using a camera. Live video is sent real time, so we see what is happening instantly without being human physically present. Automatic detection of motion or instruction. Sensor and software automatically detect movement or unauthorized entry. If someone enters a restricted area, the system can identify without human help, reduce human effort, and improve security. Since the robot monitors the area on its own, fewer security guards are required. This reduces human workload and increases safety because the system works continuously. Remote access and control. The robot the robot camera can be controlled from remote locations using mobile phones or computers. Users can move robots
Of this project. This project concludes that the smart surveillance robot is a modern and effective solution to today's security challenges. By combining robotics, sensors, and wireless communication, conclusion of this project, the project concludes that the smart surveillance robot a modern and effective solution to today's security challenges. By combining robotics, sensors, and wireless communication technologies, the system is capable of performing intelligent and autonomous surveillance with very little human involvement. This reduces the need of constant manual monitoring and increases reliability. The robot can monitor areas in real time, identify suspicious activities, and send live data and alerts instantly to control the system. Because of this security, personnel can respond faster or more efficiently to potential threats, improving overall safety. Additionally, the project highlights the strong potential of automation and smart technologies in the field of security. System can be effectively used in residential industry enhance security coverage efficiently and safety in various environment. Thank you.
ಇಲ್ಲ ಇನ್ಫ್ಯೂಷನ್ ಹೇಳಕ್ಕೆ ಬಂದು